Hello everyone, we are back with another video, and in this video we are going to be discussing the second internal solutions of numerical analysis and design in International Institute of Professional Studies. My name is Sanidhya Rawat and I'm currently in fourth semester. So let's start discussing the solutions. Mm, just a moment. So here are the MCQs. Let's go one by one from each of these. Which of the following interpolation technique is used for finding the values of a function at a point lying outside the known data? So we know that in Newton forward interpolation and Newton backward interpolation, uh, it works for a very defined range. I mean, both these interpolation in option A and B work if we have a given range and uh, we are asked that we have to find points which lie outside the known data points. So, for finding this, we have Newton divided difference interpolation because even if we go to Lagrange's interpolation, it works for non-equidistant points, and the remaining option that we have is Newton divided difference interpolation. Which of the following is not a disadvantage of Newton interpolation? That is the second question. So if it is not a disadvantage, then it has to be an advantage. So let's go option by option. It cannot be used for large values of n. No, it's not a disadvantage. Um, it can be used for equally spaced data points. Yeah, it is true, but it is not a disadvantage. Uh, Option C is again not relevant. Then, yeah, we are left with option D that it is computationally intensive. That is definitely an advantage. So let's move on to the third question. Which of the following interpolation technique uh, is used to find the value of function at a line at points lying before the known data points? As in the first question, I've mentioned that um, Newton forward and Newton backward work in a defined data range. And here we have to find the values of a function at a point length before the known data point. So yeah, definitely Newton backward interpolation is used in this case. Let's move on to the next question. Um, which of the following interpolation technique uses polynomial of a degree n minus 1 to interpolate n data points? Um, For n data points, we have n minus 1 polynomial. For n data points, we use a polynomial of n minus 1 degree, which is the case in Lagrange interpolation. So here Lagrange interpolation is going to be our correct answer. Let's move on to the fifth question. Which of the following is not a disadvantage of Newton backward interpolation? Uh, it requires equally spaced data points. No, it's not the case. It is sensitive to error in data points. No, it is definitely not the case. It is computationally. We have been asked which of the following is not a disadvantage. It is computation intensive. We saw earlier that it's an advantage. So we saw earlier that it is not the case. So we are left with option C. It can be used for large values of n. So option C is going to be our answer. Um, which of the following interpolation technique is used for finding the values of a function at a point lying between the data points? So we have been given almost the same options. So let me explain step by step. In Newton forward interpolation, we use it to find the values for the starting data. Let's say if we have six datas, one, two, three, four, five, six, top to bottom. If we have to find the value between data number one and data number two, then we are going to use Newton forward interpolation. But if we have to find if we have to move backwards, like from last to the start, let's assume we have to find the value between fifth data and the sixth data. Then use Newton backward interpolation. and we use Lagrange interpolation for any values in the table. And definitely now we are left with Newton divided difference interpolation. And yeah, it's used for outside of the range. So our correct answer would be Lagrange's interpolation. Now let's move on to the seventh question. In the seventh question, what is which of the following is the correct formula for Newton divided difference interpolation? Just a second. Yeah, A1 is the correct answer because firstly the formula starts with x naught, the first element, then it goes as it is seen in option A. Now let's move to question number 8. In question number 8, uh, which of the following is the correct formula for the first divided difference in Newton divided difference interpolation? Mm, Let's go through the options. Fx of I is equals to fxi. Fx of I is equals to fxi plus 1 minus fxi c. Fx of I is equals to fxi plus 1 minus fxi divided by xi plus 1 minus xi. No, these are not the formulas. We know that the formula of Newton divided interpolation is that the f x of I, the ith element minus one element prior to it, or the function of one element prior to it, divided by the xi element subtracted one element backward to it, xi minus one. So yeah, definitely matching to what I said, D is the most accurate option that we can come across, and hence D is the answer. Let's move on to question number 9. Um, what is the basic difference between Newton forward and backward interpolation methods? So let me just go through the options. Yeah, as I explained earlier in the question, that Newton forward and Newton backward are used in the respective cases where, firstly, the range should be defined. The range should be defined, and secondly, the main difference is between Newton forward interpolation and Newton backward interpolation is that they respectively use forward differences and backward differences. For instance, Newton forward differences is used when we need to calculate elements from start to end. I mean, there are six elements. We have to go from first to second. Newton forward is used. We have to go from sixth to fifth. Then Newton backward is used. So yeah, A is going to be our answer. Moving on to question number 10. In Newton divided difference formula, what is the purpose of using the differences? Mm, yeah, here the answer would be definitely to increase the accuracy of the interpolation. Moving on to question number 11. Which of the following interpolation methods is not based on polynomial approximation? Moving on, option by option, Newton forward, Newton backward, Lagrange interpolation. It's all used on the polynomial approach. Yeah, but D divided difference interpolation, it's not based on the polynomial approach. So yeah, D is going to be our answer. Moving on to question number 12. Question number 12, difference between Newton divided differences and difference interpolation and Lagrange's interpolation. So yeah, um, as in the former question, we saw that Newton divided differences interpolation uses divided differences, whereas Lagrange's interpolation uses polynomial interpolation. So yeah, that is going to be answer, and hence C would be our answer. Question number 13, which of the following interpolation is more stable for unevenly spaced data points? We know that Lagrange's interpolation is used for unevenly spaced data, where there are uneven gas between the intervals, and Newton forward, Newton backward, divided difference. They are all used when we have equal intervals. So yeah, definitely Lagrange's interpolation is going to be our answer. Moving on to question number 14. Question number 14, which of the following interpolation is known as the method of finite differences? The divided difference interpolation is known as the method of finite differences. So C is going to be our answer. What is the order of the polynomial used in the Newton's forward interpolation? Um, n minus one. Yeah, because we move from top to bottom, first to second, second to third, that way. So yeah, it's going to be n minus one. 16. Which of the following interpolation method uses the concept of interpolation error? Um, yeah, Lagrange's interpolation, uneven intervals again. So yeah, the concept of error is used. Which of the following interpolation methods can be used to interpolate functions with complex values? Um, yeah, Lagrange's interpolation. Again, the properties of the same interpolation technique. What is the drawback of using a high order difference in Newton divided difference interpolation? See, if we use a high order difference in Newton divided interpolation, then definitely the computational complexity is going to increase. It's going to take a lot of memory space, and hence the chances of error are going to be increased drastically. Also, we can lose our precision. So, yeah, going with all of that, C is our answer. Moving on to question number 19. What is the main difference between Newton-Cotes and Gaussian quadrature formula for numerical integration? Um, so going through the options, A is going to be our correct answer because Newton-Cotes uses equidistance point, whereas Gaussian quadrature uses non-equidistant points. Moving on to the last question, which of the following is an example of Newton-Cotes formula for numerical integration? So um, here the answer is going to be D, both A and C. Simpson's three-eight rule and trapezoidal rule. Uh, so yeah, that's it for this video. Thank you for watching, and we'll continue the analysis of second internal paper in the next video, in which we are going to discuss the remaining 20 questions. Till then, bye.